Guillaume from the Instituto Astrofisica de Canarias.
So hi everyone, I'm sorry I have to give this talk remotely. I'm not able to join you. And so I'm going to speak about how we can reconstruct the chemo-dynamical evolution of the Milky Way and more broadly of the local group using CFHT data and how a strong connection with the Canarias can be made to get access not only to the metallicity and the photometry access, but also to get access to spectroscopic data sets, also to enable the dynamical aspect of the Milky Way. So I think I don't have to convince you a lot of all the strengths of MegaCam in the last couple of years, including either the stellar halo of the Milky Way, of Andromeda, with PANDAS, or by detecting new structures in the Milky Way, as we have been doing with CFIs and unions. I think this was already shown, for example, by Alan and John Shaw yesterday, with the discovery of several streams, discovery of new galaxies, and some trash can, if I remember well the expression used by Alan. And also to study also the disk of the Milky Way. As you can see here, the high elevation of the Milky Way due to the flaring of the disk, which we assume to be caused by the passage of the Sagittarius streams into the disk that did a dynamical heating and generating this flare of the disk. And I think more recently, we have also a very nice paper, which was a kind of a dream that we had for a very long time, combining two large programs of CFHT, which are CFIS unions and Pristine, because a lot of the members of the two surveys are combined into two surveys, And so we are thinking that we could combine this data to get really precise data access and to unravel the outer part of the Milky Way. It's what we have been doing with Manuel Bayer, who selected BHBs along the Sagittarius streams, identify either using Pristine or CFIS photometry, or both. And with that, we were able to measure, we were able to measure the enclosed mass of the Milky Way within the radius of 100 kiloparsec, and we were able to find that in general, this data tend to produce, or to tell us that the mass of the Milky Way at distances is around 10% smaller than what was predicted before. And so a lot of things can be done now with the new large program of CFHT, and a lot of connection can be done with either the ILC, so the Instituto de Astrofisica de Canarias, or the Canarias observatories. And I've seen that I'm not the first one to speak of the Canaries, since some was speaking of them before. So our idea, for example, getting access to deep photometric data, such as done with CFIS, but also with the new Anubis project proposed by Stephen yesterday, we could get access to the metallicity of the stars really deeply. And with that, for example, we have the Chronogal team at the IEC that aim to reconstruct the age metallicity distribution of the stars in the Milky Way, and getting access to the U-band in particular, which is extremely metallicity sensitive, will help us a lot to unravel the chemo-dynamical evolution of the Milky Way by enabling us to go at larger distances and to see and to compare the local bubbles that we have around the Milky Way and to compare it with other regions in our galaxy. Along the other things, we can also study, for example, very deeply dwarf satellite galaxy in the Milky Way, in particular the outer part. And all of this can also be nicely complemented if you get access to spectroscopic data, either such as DAISY, for example, but in particular also with some spectroscopic data that you can access from the Canaries, either with the WAVE instrument, which is a spectrograph on the William Herschel telescope, which is in calibration mode right now. And it has two modes, one a MOS with 1,000 fibers, with high and low resolution, with the numbers that you can see here, and also a naive view. And there is a lot of interest of people in WAVE to get access to CFHT, in particular for people in the WAVE apparative surveys, for example, to be able to get access to MegaCam, to study the outer part of the galaxy and stellar halo of external galaxies, but also for us, people that study the Milky Way, because in that cases we can go deeper and we can complement our data with photometric surveys that tend to be more complete than spectroscopic surveys, as you will be with WAVE. In the parallel, you can also imagine that including the GTC's data in in collaboration with the CFHT in general, using either MEGARA, which is a high-resolution spectrograph mode with either MOS or an IFU on a 10.4 meter GTC telescope, or the OSIRIS, which is a more broadband photometry or lower resolution long-slit spectrograph, can also help us to study the outer parts of galaxies, or in particular in our own galaxy or of M31. So if you have something to take from this talk is, if you have any idea of what we can do with spectroscopic data, please contact us in the Canaries. We'll be really happy to contribute with the CFHT and to maintain the strong connection that already exists. Thanks.
Questions?
Guillaume, you mentioned that with the BHB sample, you can get the Milky Way mass, but Pristine and Union are all photometry surveys. So can you explain a little bit how you get the mass from the Milky Way with this sample?
Yes, so we identify the BHBs with Pristine and CFIs using photometric data, and then we ask for extra complementary data sets on ESO to get the spectroscopy, to get the radial velocities. And then we compare with simulations, and we are able to see that in general, the simulation to reproduce the data need to be but around 10% further away, which also have an implication in the mass in general. So that's why you have a strong connection, again, between spectroscopic data set and the photometry, and why, for example, the telescope that we have now in the Canaries might help a lot to complement the data acquired with CFHT.
Okay, thank you very much.